let's get right to it. The first thing we want to do is we're going to need a class. Not all that doesn't work. We want a list node. This will be the node that holds all our data. With the constructor, we're going to take in data. We say this dot data equal to data. And since there will be nothing attached to it when we put it in, next will be null. Next, we need somewhere to put this. And let's just call it linked list. Again, we're going to have a constructor. This time we're going to set the head to null by default. In the constructor, if the head is passed, the head. Don't need two spaces there. There. No. That has all that wrapped up. So the first thing we're going to want to do is we're going to want to insert some data. So let's make a method. We'll call insert at end, because this method will insert that data at the end. First things first, if we come into this list and it's empty, we don't really need to iterate and waste a lot of time. So it's empty. Skip the if block here and let's go straight to the else. Let's save this dot head. Was a new list node for data. Perfect. Now, if there is something in the list, we need a way to traverse the list until we get to the end where the value is null. So we could say let the current node list.head, and while current node.next evaluates to true, we can do current node equals current node.next. And basically what this will do is we'll keep going through. So we'll go from current node.next to current node.next to current node.next until one of them equals null. When it equals null, it's going to kick us out here. And we can say current node.next is equal to new this node data. A little bit, look a little prettier. Add some semicolons for the purists. Don't normally do that. Let's say let's create an instance of our linked list class. Let's go backwards here. So we're always going to be only at first data. Then second data. One more. Third data. After all this, let's just console log it all out and see what it looks like. Perfect. So we went through, it is working. And what happened is, if we really pay attention to what happened first on so the first data, this was null. We skipped here and we just made it 1. Second time we went through, we had first data. So we went to the next first data. That was null. So we assigned that to second data. Third time we went through here, we ended up at second data.next, which was null. And then we added our third data, which is not visible here. Let's address that next. All right. let's display this a little cleaner than what we've got going on here. So let's make a new one called display. It's not taking anything. And in display, let's do current node again, list.head, current node, console.log out, current node.data. You could return current node.data here. But just for the sake of this, I'm just going to console log it out so we can see it. Then let's increment. We'll do current node.next. And that should be it. So what'll happen is we'll come in here and grab the first one. While we have something in it, we're going to move on to the next. We're going to console log out its data. So after we get to the part where the current node.next is null, current node is going to equal null, and we should exit our loop. So let's replace this with list.display. Let's run it. And there we go. Next up, let's insert one at the start rather than at the end. All right. So once again, let's check if this .head exists. If it doesn't, then we can just skip all this and go straight to there. If it does exist, let's create a placeholder for our old head. And I'll save this .head is equal to new list node, and this .head .next now be the old head. And what's going on here is we're going to replace the head here. The head is going to become, it's going to have a next value. The next value is going to be old head. And if we think about the way our list works, the old head already has the downstream chains tied to it. So the .next property of this will be everything downstream. Let's give it a try and see if it works. Insert. Let's start. Now I am first data. Sounds a little proud. All right. If this works, we should now see now in first data pop up first one. And there we go. All right, next thing we want to do is we're going to need the list length. We're going to need this for the next one. This is not the best way to do it because we have to traverse the whole entire thing just to get the list length. We could add a class variable and just increment and increment depending on what we're doing, but in this case, we're going to do it this way. So let's get our length set to 0. Current node equal this .head, and now current node. First things first, we spelled length right. Let's increment that by 1. And then let's increment our current node. And after all this is done, let's return length. Sweet. So let's display it out and do this dot get length. Do need to wrap this in a console log so we can see it because we are just returning a value here. Let's try it out. Bam, 4. 1, 2, 3, 4. Last but not least, let's do a little bit more complicated one. Not too bad, I hope. Let's insert at a certain index. In this case, we're going to take in data. We're going to type in the index we want to put in at. First things first, let's check if index is equal to 0. We can reuse some of our code here. So let's just reuse insert at start. Let's put our data there. Now let's if index is greater than this dot. Let's get our list length. Or index is less than 0. Basically what this is saying is if our index is too big and they want to put it in position or at index 10 and we only have 5 items in our list, no. And if they want to put it at a negative value, we're just going to say no. You could handle some of that stuff differently, but in this case, I'm just going to console log out. The index is out of range or a negative value. Get out of here. All right, now we're getting to the meat and potatoes part. Let's just do else. So in this case, we are assuming that we have something good to work with here. And let's get a placeholder for our current node again. Let's get a placeholder for our previous node, but we're not going to put a value there. In a second. Now let's start a for loop. I equals 0. Well, I is less than index. And let's increment I. Proper to have a semicolon node? No, don't like it. All right. What we're going to do is we're going to take previous node and let's make it current node. So let's store our previous node somewhere because we're going to increment. And then let's make our current node equal to current node.next. So this way, as we increment through it, we've saved our previous node somewhere. So when we get kicked out of this for loop, previous node will be the last known node prior to hitting our index. Let's move on. Let's do previous node.next. Going to equal our new this node. This is actually where we're going to insert it. So we're going to insert it right after previous node. And then our current node, we need to assign a value to it now. So an easy way to access it now is going to be next.next. Previous node.next. Okay, so we go up. Previous node.next is now this. So we've now accessed this. And if we remember from higher up, this next value is currently null. Let's give that a next value. Let's assign that to the current value here. We grabbed as the last node where we kind of split this and put it in here. All right. So now it should be good to go. I hope so. We'll find out. All right. So let's insert an index. We can take in data. Inserted. Let's insert that and index. And let's go 2. So index 2, which should actually be 0, 1, 2. Well, we should go to 5. Let's leave that there. Oop. I is not defined. What did I do? All right. So we wanted it inserted at index 2, 0, 1, 2. Here we are. Our list length is now 5. Thanks so much for watching, and hopefully you got something out of this.